Alright guys, today we're going to look at how to solve equations with factoring. Now the reason basic is in parentheses there in our objective is because we're going to actually learn how to solve slightly more complex equations with factoring, but for right now we're only looking at very basic ones, but we're going to be doing that at a different time later in the year. But for right now we're just going to learn some basic ones. So before we start, I've got three problems here I want you to factor. Again, you should really try doing these without splitting the middle term. Okay, if you need to show that work, of course that's fine, but try to be doing these as quickly as you can. If you can just jump straight to your answer, like for me, just as a reminder, I'll do A. I'm looking for numbers that multiply to 4, the last 4, and add to the middle 4. That's 2 and 2. When it's just x squared at the beginning, we can just jump straight to this. Now the other way that I could write this, I can write this in a different way. I could write this as x plus 2 quantity squared. Okay? So try factoring both of the next two, pause, and then come back. Alright, I'm assuming you've done that. For this one, you should have gotten x plus 4 quantity squared, or x plus 4 times x plus 4, but I want you to write it this way, just like we did up here. And this one, you should have gotten x minus 5 quantity squared. Okay, so obviously I was trying to make a point here. See how all these factored into something squared? Well, we utilized this kind of in our last lesson, right? We had this equal to a number, and then we solved the equation. So, look at this. I created three problems that used this basic factoring down here. So let's see how I solve. On the left side, I can factor to x plus 2 squared, still equal to 36. That's just factoring. I know how to solve this already. All I did is add one step onto what you've already done. Take the square root of both sides. Square root of 36 is 6. The square root of x plus 2 squared is the absolute value of x plus 2, because remember, I need that to be positive. So now there's two possible answers that I could get here. Split it into two equations. X plus 2 equals 6 or negative 6. Solve each of those equations by, again, I'm not writing minus 2 on both sides, but that's what's happening. I'm subtracting 2 from both sides. I get x equals 4 and x equals negative 8. We can go all the way back to the beginning and check our answers, but both of these work. Okay, so go ahead and try the next one, which is based on B from above, and then go ahead and try C too. C is a little bit tricky, but see if you can kind of figure out what I'm getting at there. Okay, hopefully you did that, because if you didn't, you're kind of not really getting the point of the video, are you? X plus 4 squared is this. Square root of both sides. This one was very much like the first one. Split it into 2. And then subtract 7, or excuse me, subtract 4 from both sides in each of these equations. We get x equals 3 and x equals negative 11. Both answers work. It's fantastic. Now C, we've never factored with decimals. Okay, and there is a good reason, however, to know how to factor with decimals in this case. There's a couple different ways throughout this chapter we're going to learn how to solve this type of equation, but if you kind of get what I'm getting at, look at the pattern that all of these followed. All of these we were able to factor into two of the same thing. 2 times 2 is 4, 2 plus 2 is 4. 4 times 4 is 16, 4 plus 4 is 8. 5 times 5 is 25, negative 5 plus negative 5 is negative 10. Then we look down here. So we'd be looking for numbers that multiply to 6.25 and add to 5. Now use a little logic. There's lots of things that multiply to 6.25, but think for a second. We want two of the same number. Ideally, otherwise we can't solve it using this method. So think of what two of the same number will add to 5. Well, for me, 2.5 and 2.5, 2.5. Two 2.5s will add to 5. Do they also multiply to 6.25? Yes, they do. Okay, so we can actually factor this into x plus 2.5 squared. What you're seeing is an example of what we call perfect square trinomials. Okay, and what we're eventually going to do in the next lesson is we're going to try to figure out what is the relationship between that second and third number in perfect square trinomials that they always have in common. Hopefully you see what that pattern is already, but if you don't, that's okay. It's part of what we're covering in the next lesson. So split it up into two equations. And we're going to get two decimal answers, but they're going to be fairly pretty decimal answers. Subtract 2.5, we get 3.5 for this one, and negative 8.5 for this one. Woohoo! That's it for today. The decimal one is probably the most tricky, but again, just keep in mind, all of these examples we're trying to make really easy ones, okay? We're looking for two of the same number that add to the middle and multiply to the end. Not just random numbers that multiply to the end, because if they're not the same number, we don't get the squared, and we can't utilize what we know about square roots. That's it for this video. Try some practice problems, take a concept quiz.